So in this case, we have got a typical exam question that we are going to work on revising for our term 3 examinations, our term 3 common test. So that is the Limpopo province that we are having. That is for our grade 9 mathematics, which was a term 3 common test. So that was out of 50 and 1 hour test. Let's see. Remember, you're supposed to answer the questions as you are given all the questions. In this case, we have got this question paper consists of 7 pages, including cover page, all right? Then your instructions and information. Read the following instructions carefully before answering the questions. All right, so we have got 4 questions. Answer all of the questions, then answer in the spaces provided. Okay, answers alone we will not necessarily earn full marks. All right, answers alone we will not necessarily earn full marks, meaning to say show working. All right, so that is it, guys. Make sure that you also write neatly on your presentation. On question number 1, we are given a multiple choice question that was select by circling the correct answer next to the corresponding questions below. That was for example 1.6. The answer is A. All right, that is it, guys. Let us see our questions that we are given. 1.1, the gradient of the following equation is the equation given as y is equal to minus 3x minus 1. What is the gradient? Remember, if I write my equation in the form y is equal to mx plus c, m represents the gradient. The gradient. So that is the coefficient of x. What is the coefficient of x? That is your gradient. So in this case, our gradient is -3, the coefficient of x. So the best answer where we've got -3 is on A. All right. Moving on to another part. 2 angles are called complementary when their measures add up to what? They add up to 90 degrees for complementary. 180 it is for supplementary. Remember, there is supplementary angles. That is for 180. For complementary, it is 90 degrees. So the best answer was going to be C. All right, complete on 1.3. Complete the statement. In a right-angled triangle, where there is a 90-degree angle, all right? One angle is more than 90 degrees. One angle is more than 90. This is impossible, guys. It cannot be. We cannot have any other angle more than, because remember, angles in a triangle, they add up to 180. So meaning to say, if this angle is 90 degrees, from 180 degrees, we are going to have 90 degrees, meaning these 2 angles that are remaining, they add up to 90 degrees. If you add this angle to this one, you must have the remaining 90 degrees. So we cannot have anything bigger than 90 degrees. So this is totally wrong. All angles are less than 90 degrees. This is the problem. All is the problem. These 2, they are less than 90 degrees, but this one is already 90 degrees, a right angle. So if it is A, B, C, B is already what? 90 degrees. So we cannot say all of them, they are less than. So this is totally wrong. All angles are equal. No. That's not an equilateral triangle, which is 60, 60, 60. It's not. One angle is equal to 90 degrees. All right, that is exactly it. One angle is 90. That right angle is what? 90 degrees. So that was the correct answer. One angle is equal to 90 degrees. Multiple choice questions. You work with the answers that you're given. Sometimes, like this question, you figure out from what you're given. These ones, they do not work. They cannot be on a right angle triangle, right? So let's communicate, guys, even on the comment section. Maybe there is something that you want to share about this question. All right, 1.4. What is the name of the triangle below? They are equal angles and also equal sides. So that's an equilateral triangle. The best answer there is equilateral. It cannot be isosceles. Isosceles, we talk about what? Only two sides that are supposed to be equal. Scalene, we do not have anything that is to be considered equal. A right angled triangle is the one that is at 90 degrees, and the sides cannot be equal, all of them. So the best answer was an equilateral triangle. Consider the diagram below. Lines AB and CD, they intersect at E. All right, these two lines, they intersect at E. Why is CEB equal to AEB? AEB. All right. No. They wanted to say AED, not B. AED. AED. Why are they equal? Those are referred to as what? Vertically opposite angles. The angles that are formed where two straight lines intersect. Remember that. We talk of vertically opposite angles. So the best answer there was going to be on D. All right. That is our question 1.5. Then moving on to question 2. We are given in that case to calculate the x-intercept and y-intercept of this graph. Show your workings. X-intercept, we do understand that's a condition where y is equal to 0 in the x-axis. If a line crosses the x-intercept, y is equal to 0. So you can substitute into the equation, y is equal to 2x minus 4. Y is what? Is 0. So we can solve for x. We have an equation. Remember your equations, guys, from your grade 8 mathematics. You have been dealing with equations, linear equations. Take the minus 4 to the other side of the equation. It's going to be a positive 0 plus 4, which is 4. So 4 is equal to 2x. A product. How do we get rid of 2? Divide by 2 both sides. So 4 divided by 2 is going to be 2. So x is 2. Therefore, our x-intercept, since a point is made up of x and y like this, x, we have the x value, which is 2. What about the y value? Remember, for the x-intercept, we said what? Y is 0. So that's a point. That's our x-intercept. For the y-intercept, if the line is referred to or is drawn or if a line is drawn, then the point is referred to as the y-intercept. On that condition, where it lies in the y-axis, x will be equal to 0 throughout. So you can take that one as an advantage. For the y-intercept, x must be equal to 0. So thus we can solve for y in this equation. Y is equal to 2x minus 4. Substitute in place of x to determine the y value. So our x is what? Our x is 0 in that case, all right? So that is it. 2 times 0, that's 0 minus 4. So y is minus 4. So therefore, we can have it as a point, or you can just leave it as it is, or you can have it as a point. X is 0, y is minus 4. That is our y-intercept. So this is how these questions are given as. Then from that information, draw the graph given, all right? Draw the graph given in 2.1. Draw the graph given in 2.1 in the Cartesian plane below. In 2.1, that is here where we are given this graph or the equation of y is equal to 2x minus 4. So for us to draw the graph, We simply need our x-intercept. Remember, x is at what? At 2. So x-intercept exactly in the x-axis. Exactly in the x-axis, where x is 2. That is in the x-axis. Where x is 2, you mark a point. That's your x-intercept. The y-intercept, we also calculated that at minus 4, y is what? Negative 4. Exactly in the y-axis, exactly on this line, where y is negative 4. You mark a point. That's your y-intercept. With these 2 points, our x-intercept, our y-intercept, a line can be drawn by joining the 2 points using your ruler. You can join these two. You have got what? A straight line. That is the graph by joining the 2 points. So we have the graph of y is equal to 2x minus 4. From these two, it is enough. All right? From the two that we are given, x-intercept, y-intercept, we can have a straight line. So do revise how to draw or to sketch your straight lines. Also, it is important. All right. Determine the gradient of the line that goes through the following points given A and B. Remember the gradient of a line from the change in y over the change in x. All right, y2 minus y1 over x2 minus x1. So I can just label this x1, y1, x2, y2. So that's m as our gradient. Y2, that's 12, minus y1, which is 10 over x2, which is 6, minus x1, which is 2. So that was going to give us the gradient. Or you can use the other way, y1 minus y2 over x1 minus x2. Still, you're going to have the same answer on your gradient. All right, that's 12 minus 10, which is 2 over 4. That's divided by 2, that is 1 over 2. So our gradient was going to be 1 over 2, change in y over change in x. On 2.4, determine the equation of the line in 2.3. The equation of the line in 2.3, this one. In this form, y is equal to mx plus c. Remember from 2.3, here we have the gradient already. Y is equal to mx plus c, where our gradient m is 1 over 2. So that's 1 over 2x plus c. So c is the y-intercept, which can be taken from the point if x is 0. Then we've got the y value there. But we do not have that. So we cannot substitute to say our y-intercept is 6 or is 7 or what. We do not have the point, maybe 0.6 or it can be 0.7. You just substitute there because that's your y-intercept. We do not have that. So what are we going to do? We substitute any of these 2 points that we are given, A and B. You take one of your choice. So in this case, I'm going to take A. We substitute that point A as it is. It is 2 versus 10. 2 as to 10, like that. So that's we've got the X value, the Y value. So you substitute in place of X, in place of Y. Then solve for C. Where you see the y, you substitute with 10. So 10 is equal to what? 10 is equal to 1 over 2 times x, where our x is what? Our x is 2. All right, that's our x value plus c. That's it. Substitute the y in place of y, the x in place of x. Then solve for C as you have got an equation. Now you're supposed to solve for C. Okay, so let's solve for C in that case. 1 over 2 times 2, that is going to give us a 1. Can even use your calculator. 1 over 2 times a 2 like this. That's a 1. All right, so that is a 1. So 10 is equal to what? 10 is equal to 1 plus C. You want to solve for c, so take 1 to the other side. That was going to be a negative 10 minus 1. The moment it crosses the equal sign, it changes the sign. So that was going to give us a 9. 9 is equal to 9 is equal to c, meaning to say the c value is 9. With the c, well, our y-intercept here, let's substitute. So therefore, y is equal to, as it is here, 1 over 2x, which is half of x, plus the c that you calculated. What is your c? Positive 9 as it is. So that is now the equation of the straight line. We are now having the equation of the straight line. That is how we attempt these questions. So many ways of attempting these typical questions. On question number 3, which is under the geometry of straight lines, we talked about these head questions before. So let's see. 3.1, solve for x, y, and z with reasons in figure below. All right, in the figure below that we are given, let's find x, y, and z, okay? X, okay, direct here angles on a straight line. So we do understand that for angles in a straight line, we can simply work with that one direct, all right? So that's for x. If we add x plus 40 degrees, all right, so it's x plus 40 degrees plus 60 degrees. This must give us 180 degrees angles on a straight line. All right, so that's a direct question here. Angles on a straight line. Okay, so that's it. X, considering your like terms, add these two, 40 plus 60, that's 100, which is equal to 180. So x is equal to what? Take the 100 to the other side. That was going to be 180 minus, it changes the sign, remember? So it's going to be minus 100. So that's 80 degrees. So x is equal to 80 degrees, this one, all right? Angles on a straight line, all right? Then for angle y, we can consider the parallel lines. These two lines, they are parallel. So we are forming a Z alternate angles, Z angles, alternate angles. So thus, by this one, y is equal to what? Y is equal to 40 degrees. That's for alternate angles. All right? From our parallel lines. So it means y here is 40 degrees. So substitute whatever that you calculated. All right, let's move on to another one, which is z. Angles in a triangle here. We can work with that one. All right, angles in a triangle. That's if I add the z plus the 40 degrees representing the y that I calculated plus the 60 degrees, we must obtain 180 degrees angles in a what? Angles in a triangle. All right, those are angles in a triangle which add up to 180 degrees. So z plus 40 plus 40, that is 100, is equal to 180 degrees. So z is going to be this to the other side, 180 degrees minus 100 degrees. Remember, it was a positive. It's going to change to a negative. So z is 80 degrees. All right, z is 80 degrees. Angles in a triangle. Or we can work with the parallel lines where we form f corresponding angles. F. Remember, where we form f like this from our parallel lines, corresponding angles are equal. We are forming an f here like this, like this. All right, one is inside, the other one is outside. One is inside, the other one is outside. So z, another way was going to be from what? corresponding angle Z is equal to 80 degrees. All right, Z is equal to 80 degrees from corresponding angles. From corresponding angles. That's another way that we could have used as we are given those parallel lines. All right. Okay. That is it. That is it. That is it on this one. 6 marks. We have answered everything. Let's check another one. On 3.2, solve for x, y. Okay, for x and y there with reasons in fig below. We are supposed to solve for x and y. Okay, there can be, let's start with x. Can work out a straight line there. H to I like this. It's a straight line. So angles on a straight line add up to 180 degrees. That's x here plus the right angle, which is 90 degrees. So x plus 90 degrees plus this 32 degrees. We must obtain 180 degrees. What are we referring to? Angles on a straight line. Okay, as we had this one before. So that is how we can simply work out these typical questions. Or you could have started by finding why the another way. Okay, no problem. Let's see what are we going to have. 90 plus 32, which is 122. 122 degrees is equal to 180 degrees. All right, so x will be equal to what? You take this one to the other side. It's going to be 180 degrees minus 122. That's going to be 180 minus 122, which is what? 58 degrees. So x is going to be 58 degrees. All right, that is it. We can have our angle x from there, angles on a straight line. Or you could have started by finding y there. As you can see, this one, it's a straight line from HI like this. That's a straight line. This one is also a straight line, vertically opposite angles. You find y first. Y is equal to 32 degrees. You're talking about what? Vertically opposite angles. Remember, they are equal. So if y is 32 degrees, we can find x using this one. It's a 90 degrees, this one, as we have got angles on a straight line. So we can also find x by subtracting this 32 degrees from 90 degrees. Still, we're going to have the same x that we obtained before, which is 58 degrees. Guys, there's so many ways. So many ways, as long as you're obtaining those values that we had to from our calculations and with the reasons. The reason is from what? Your geometry, mathematical reason that is to be given. That is to be given there. So work out as many questions. Given this shape, that it is a parallelogram, solve for x with reason. When this is a parallelogram, remember I told you guys on your properties that the adjacent angles here, they are supposed to add up to 180 degrees. Even if you do not understand that, the moment that they give you it's a parallelogram, what is it that you see? Co-interior angles. What is that you know about these C angles? They add up to 180 degrees. Add up to 180 degrees. Co-interior angles. So you can work with the property of a triangle. The property of a parallelogram. You can work with the property of what? Parallel lines. This one, adding these two, we are talking about the adjacent angles of a parallelogram. They add up to 180. You can use the co-interior angles. It's up to you guys. All right. So x plus 50 degrees. When added to 2x minus 20 degrees, we must obtain 180 degrees. Angles on a, that is adjacent angles of a parallelogram, or you can use co-interior angles. These are co-interior angles since AB is parallel to DC. All right, since our AB is parallel to DC or CD. Those are co-interior angles where we form a C. So thus, we have formed an equation where we can solve for what? Where we can solve for x. So let us collect our like terms. There is x here. There is 2x. These are like terms. So that's 1x, 1 plus 2, which is 3. So 3x, you add the numbers 50 minus 20, which is 30. 50 minus 20, that's what? 30, is equal to 180 degrees. So solving for x, we can take the 30 to the other side. It was going to be a negative there. That's 180 degrees minus 30. You can use your calculator, guys, for the sake of those ones who are not good with numbers. 180 minus 30. Use your calculator. Do not even worry about that. That was going to give you 150 degrees. So dividing by 3, our x was going to give us 50 degrees. Divide by 3 like this. That is 50 degrees. Solve for x. Just like that. So guys, it is in your hands. On question 4, we are given list 4 minimum conditions which must be met for 2 triangles to be congruent. If we say 2 triangles are congruent, those are the conditions, the reasons that you put there. When you are writing your answers, which reasons that you use? Remember, we talk about side, side, side. We talk about side, angle, side. We talk about angle, angle, side, which can be referred to as side, angle, angle, which can also be referred to as angle, side, angle. There is right angle, hypotenuse, side. Those are the conditions, guys, for your triangles to be congruent. The conditions, those are the reasons that you put there when you say 2 triangles are congruent. There's a reason that you put. What is the reason? We can have this one, any of these. Remember, we mentioned this on our introduction. So if you check now on question 4.2, they are saying prove that these two, they are congruent. To prove that they are congruent, you must have any one of these reasons, any one of these. Those are the conditions. If the triangles can meet these any one of these conditions, therefore those triangles are congruent. That is what we mean there. They're exactly the same. So in this case, they're saying in quadrilateral ABCD, this one that you're given with this side parallel to this and also equal, AB equal to that. Prove that ABC is congruent to triangle CDA. So to prove, we must have that any one of those conditions, like I said, to prove that. Any one of these. So let's check. If we are to consider the triangles that we're supposed to prove is this one, ABC, ABC. All right, let's check. This is the triangle and CDA, this other triangle. Is there anything that we can use? All right, from triangle ABC, from triangle ABC compared to triangle CDA, we can see that there is a common side, AC, which is the same side. All right. We also consider in that case this one, AB, from A to B. A to B, all right, here from C to D. A to B, C to D. AB is equal to CD. That is given. We are given that these two, they are equal. Now at angle D, is there anything that we can talk about angle D? Angle D and angle B, there is nothing from our parallel sides. from this side that are parallel, we understand that this angle, all right, and this angle here is supposed to give us 180 degrees. That is what we understand if these two lines are parallel. And this angle and this one is supposed to give us 180. So from there, it is going to be like something that we are putting as an additional. Unless if they gave us a specific part to say this triangle and this one, I mean, this shape is as a parallelogram where we know that opposite angles are equal. We can use that statement. So from this one, we have got AB and CD as the side. The angles, let's ignore. There is something here. AC, it's a common side, this one. AC is a common side. So meaning to say, as we have got the side in this way, we are going to move this way. This side and this side. Then the angle now, because we are supposed to have this one, guys. It's either we're going to choose side, side, and the angle there. Or we can just take it as side, angle, side. But we must prove that the angle at A is equal as this angle C1. How can we prove that? Parallel lines. Look here, there is what? A Z. Alternate angles where we form a Z. So truly, angle A1 is equal to angle C1. Alternate angles. Alternate angles as AB is parallel to CD. Then we can talk about the common side, AC. So AC as the common side. It is the same side for both triangles. So meaning to say, we can say these two triangles, they are congruent. From what? Side, angle, side. So we can use that one, side, angle, side. So we can say triangle ABC is congruent to triangle CDA. There is the side. We move on to the what? To the angle and the side. So it's side, angle, side. Those are the conditions that we have been talking about before, referring before here, the minimum conditions. So in this case, this one worked for our proof, side, angle, side. So I don't know, guys, if you've got any other way of proving that those two are congruent. On question 4.3, complete the following statement by filling in the missing words. Right? Let's see. If two triangles are, then their corresponding sides are in. All right? If two angles, this is about it's not about congruent figures here. Corresponding sides, corresponding sides. We talk about the ratio of sides there. These are similar figures. So if two triangles are similar or are equiangular, remember I told you guys similar figures are referred to as what? Equiangular. All right? That is, if they are equiangular, we can refer these ones as similar figures. Then their corresponding sides are in what? Are in a proportion, are in a ratio, in the same ratio that you consider. And that ratio is given as what? Are in proportion. Same ratio throughout. Similar figures. If two triangles are equiangular or if two triangles are similar, you can use that one. Then prove that triangle ABC and this triangle DFC are similar. You have already told us that for them to be similar, they must have their sides in proportion. Ratio of sides is equal. We're talking of what? Ratio of sides being the same throughout. So that can be used as a proof. You do not have angles for you to prove that it is equiangular. to say angle A and angle D or angle A and angle E. You don't have the angles. So what is it that you can use if you do not have angles to prove that they are similar? You use the proportion, ratio of sides. So let's use ratio of sides. If the ratio of sides is equal throughout, therefore these two triangles are similar. So we can prove that if triangle ABC, if it is similar to triangle DFE, if they are actually similar, let us have the ratio of sides AB. All right, so let us have this one, ratio of sides AB over the corresponding side, which is DF. All right, over DF must be equal to BC. That is BC in that case, BC over the corresponding F2E. And this must be exactly the same, AC over what? Over DE. So it's AC over DE. We can prove that way. If this ratio is exactly the same throughout, therefore these are equal. AB, we have it, A to B, that is 4 over DF. DF, which is 9. So that's 4 over 9 there. AB, A to B. All right. A to B, DF. All right. So the way that they even wrote, guys, here it is. You see these guys also the way they give us this information, guys. Here is supposed to be A, B, C, D, E, F. They're supposed to give us this one as D, E, F here. Not the way that they wrote there, guys. You see now what happens. Anyways, let us have it this way. So this is D, E, F there, guys. D, E to F. That can actually make sense. So meaning to say AB over what? Over DE, okay? And BC over what? Over EF must be equal to AC over D to F. All right, so this can actually make sense. So AB, that is our AB, this one. A to B, which is 4, over DE, which is what? Which is 12. It must be equal to B to C, all right? BC, which is 2, over E to F, which is 6. It must be equal to AC, which is 3, over DF, which is 9. So there, it was a wrong presentation that they gave you guys there. They are supposed to give you as DEF. DEF. All right. So anyways, let us see if we are having same answer there. That is 4, 1, 3. 2 into 2, that's 1. Into 6, that's 3. 3 into 3, that's 1. Into this one, that's 3. So as you can see, we're having 1 over 3, 1 over 3, 1 over 3. Thus, the sides are in what? In proportion. Corresponding sides are in proportion. So therefore, triangle A, BC, like I said, is what? Similar to triangle DEF. Supposed to be DEF. All right. So that is how it was supposed to be given as. So the reason being, that's our corresponding sides in what? In proportion. So you can just write in short. That's corresponding sides in what? Proportion. Okay. So we can have it that way. We can have it that way. Similar figures, equiangular, which is very true. But if we do not have that, for you to prove that the triangles are similar, you can work with the proportion concept, the ratio of sides. Once you see that the ratio of sides is the same throughout, you can conclude that your triangles, they are equiangular, they are similar. So that is how you can attempt these questions. Let us do revise as many questions as we can. Like I said, these typical questions, you just have to ought to be careful. Try to understand, right? Try to understand the basics of the properties of the shapes as you have your term 3 syllabus. Work out each and every concept that you have been doing in your term 3. That is how they are going to ask those questions that you've been from the topics that you've been doing. So do not be afraid of your exams. Just prepare. All right, prepare in as much as you can. That is it, guys. Till we meet again.